we saw geometric series. Okay, so if the geometric series is 1 plus r square plus r cube plus and so on, then this series is convergent if, okay, modulus of r is less than 1, and it is divergent if r is greater than or equals to 1. Okay, and third one is oscillatory if r is less than or equals to minus 1. Okay, so these are the three cases where the nature of geometric series is, okay, different. Okay, so convergent means its sum is finite, divergent means its sum is not finite, and oscillatory means the sum is not unique. Okay, so these are the three cases. Now let me start another. Okay, so series of positive terms. Okay, so let us see series of positive terms. So if hopefully yes 50 are now. Okay, so should I start today's lecture?
Yes sir.
Okay, देखिए हर्षित कुमार पर्सनल मेल से ज्वाइन कर रहे हैं, ट्राई कर रहे हैं.
सर हर्षित कुमार नाम का कोई है नहीं सर.
ओके, मैंने अलाउ कर दिया है.
यस सर, हर्षित कुमार का कोई नहीं है. हर्षित शर्मा और हर्षित शुक्ला है सर.
अच्छा अच्छा, तो देखते हैं यहाँ पर कैसे लिंक पहुंचा उधर. रुकिए देखते हैं. हर्षित यस हर्षदीप है, हर्षदीप पांडे, हर्षदीप कुशवाहा.
हाँ सर वो है.
हर्षदीप यस हर्षित कुमार नहीं है कोई.
यार कोई नहीं.
अच्छा हर्षित कुमार है. शर्मा, हर्षित शर्मा है.
शर्मा
नहीं है
सर. हर्षित शर्मा है सर. हर्षित कुमार नहीं है. हर्षित कुमार ने लेफ्ट कर दिया.
अच्छा लिफ्ट कर दिया. ओके, है वो अपना फर्स्ट ईयर स्टूडेंट ही, किसी दूसरी ब्रांच का होगा, क्योंकि उसमें लिख के आ रहा था ना बीटेक करके कुछ आ रहा था. ओके, सो ओके कोई नहीं, स्टार्ट करते हैं. डिस्टर्ब करते हैं उसको हम देखते हैं. नहीं, पढ़ने में कोई दिक्कत नहीं है, डिस्टर्ब नहीं करना चाहिए. कोई भी बाहर का है या अंदर का है, ठीक है. सो yes, actually this lecture is already recorded. Okay, no need to record, I will send. Okay, so let us see positive term series. Okay, so if all terms after few negative terms in an infinite series are positive, suppose there is a series in which some few are first few terms may be negative and remainings are positive. Okay, actually if all the terms are positive, then it is known as series of positive terms. However, sometimes first few terms may be negative. Okay, then in that case the series is also called series of positive terms. Okay, so for example, if we take minus 10, minus 6, minus 1, plus 5, plus 12, plus 20, plus and so on, if you see first three terms are negative and remainings are positive, so it is one kind of positive term series. Okay, so by omitting these negative terms, okay, the nature of positive term series remains unchanged. Why unchanged? Because if you see this series, we are omitting these negative terms, so it is nothing but minus 10, minus 6 and minus 1. It is minus 17. So if we omit these terms, then the nature of series would be remain same, because if the series is divergent, means if the sum is infinite, then there will be no problem whether we omit or not omit these three terms. Okay, similarly if the sum is finite, okay, then the sum will remain finite whether we omit or not. Okay, so there will be no problem after omitting or after adding some few terms. Okay, so another is the series of positive terms either converges or diverges to infinity. not oscillatory? Anyone please? Why the series of positive terms never be oscillatory? Yes, dear students. Yes. Anyone?
पर ऑसिलेटरी सीरीज में किसी पॉइंट के अबाउट रोटेट सीरीज को हमेशा इंक्रीज होती जाएगी ना
हाँ, इंक्रीज हो जाएगी. Either it will be infinity or it will be some finite value. If the value is finite, then the series is convergent. Otherwise, it will be divergent. So there is no case where the sum is not unique. Sum will always be unique, either as a infinity or as a finite. Okay. So in the case of positive term series, okay, there will be no oscillatory series. Okay. So it is the, that's why it is not oscillatory. Yes. So necessary and sufficient condition. Necessary condition for convergent series. Necessary, it is not sufficient. So if a positive term series summation un is convergent, suppose the series is convergent, then its nth term will go 0 when we take n tends infinity. So if the series is convergent, then its nth term will tend 0. Okay. So suppose its nth term not tending 0, it means series is not convergent. Okay, because it is the necessary condition. Okay, so if it is not 0, then we conclude the series un is not convergent. If it is not convergent, then it must be divergent, because it is the positive term says it is either convergent or it is either divergent. Okay, so if un not tending to 0 means if un tending to non-zero value, then the series must be divergent. Okay, let us see its proof. So let Sn. So for finding the nature of positive term series or infinite series, first we take sum of first n terms. So let Sn equals to un plus u2 plus and so on plus un. So these are the first n terms. Okay. So if you see the statement of, okay, so we are taking summation series un is convergent. It means the sum Sn as n tends infinity will be some finite value. Why it will be finite? Because it is convergent series. So let limit n tends infinity Sn equals to k. So if we suppose we delete some terms, basically we are deleting one term. So also limit n tends infinity n minus 1 means sum of first n minus 1 terms, that will also be a. Okay, क्योंकि हमारी ये सीरीज कन्वर्जेंट है तो हमारा जो लिमिट होगी सेम आएगी. ओके, सो un we can write un as a sn minus sn minus 1. Okay, because un is the nth term and sn is the sum of first n terms and sn minus 1 is the sum of first n minus 1 term. So if we take difference, then we get un, that is the nth term of the series. So un equals to this one. Now take limit both side. So un, okay, so if you apply limit on right side, so first term is k and second term is also k. So we get k minus k, it means 0. So limit un n tends infinity is 0. Okay, hence proof. So when the series is convergent, then the limit n tends infinity un will always be 0. Okay, if it is not 0, it means series is not convergent. Okay, that is also known as Cauchy divergent test. Okay, it is also known as Cauchy divergent test, where limit n tends infinity un is not 0, then the series is divergent. Okay, so converse of statement is not true. Okay, we will see through some examples. Converse of this statement is not always true. So for example, if we take 1 plus 1 upon root 2 plus 1 upon root 3 plus 1 upon root 4 plus and so on, okay, plus 1 upon under root n plus and so on is divergent. Okay, so it's first sum of first n terms. So Sn equals to 1 plus 1 upon root to take first n terms up to plus 1 upon under root n. Okay, so if we replace each terms by 1 upon under root n, and okay, so it means 1 upon under root n will be less than from each terms. देखिए 1/√2 क्या हमारा 1/√3 से बड़ा है और हम क्या 1/√n से रिप्लेस कर रहे हैं. Okay, so there will be a greater inequality. Okay, so if you see right side is written n times 1/√n. So it is nothing but n into 1/√n, and this equals to √n. So Sn is greater than √n. Okay, so here if you see the inequality, if we find the nature of right side series, that is √n. Okay, and left side हमारा क्या है, ये आपका 1 plus 1/√2 up to 1/√n. So if you apply the limit on this √n, so it goes infinity. It means the right side sum is infinity, and if you see the inequality, left side sum is greater than the sum of right side, and right side sum is already infinity. It means the left side sum will also be infinity. Okay, it means the series is divergent. This series is divergent. Okay, but so hence you can see here, if you say take un equals to is 1/√n, so here un goes to 0, but the series is divergent. So converse of above statement is not true. It is the counter example. Okay, you can give it. Okay, so converse of above statement is not true. So this example we saw how it is not true. Okay, so hopefully everything is okay. Yes, yes, please. Is there any doubt? Yes, dear students. Hello. Hello.
No, sir.
Yes, sir.
Okay, तुरंत आप एक्चुअली ये आपकी सीआर की जिम्मेदारी है. ओके, जब भी मैं कोई क्वेरी या क्वेश्चन एराइज करूं तो यदि कोई जवाब नहीं दे रहा तो सीआर को जवाब देना होगा. ओके सर, आप वेट कर सकते हैं. ठीक है, आयुषपुरी इज द सीआर ना.
Yes, sir. I was waiting.
You should give the response. Okay, after few seconds it is responding. So series is divergent, but limit this is 0. Okay, so converse is not true. So finally we can state limit here. Yes,
सर वो ऊपर जो Sn जिसमें 1 plus 1/√2 plus 1/√3 greater than 1/√n लिखा था तो
हाँ, एक्चुअली ये हमने क्या किया ना, कंपैरिजन टेस्ट लगाने की कोशिश कर रहे हैं. यहाँ पर कंपेयर कर रहे हैं ना हम. क्या कंपैरिजन टेस्ट किया था आपका. हमें क्या दो सीरीज होती गई थी, हमें यहाँ पर क्या है, वैसे आप सब निकालते रहिए फिर. ये तो ठीक है. अभी हमारे पास इंफॉर्मेशन क्या कंपैरिजन टेस्ट के बारे में.
okay.
Okay, till now we have the information about comparison test only, so we are trying to apply that test only. Okay, so we have to show it is divergent, so through some inequality. Okay, so Sn is greater than, if we replace, if you take 1. Okay, so 1/√n हमने क्या लिया, n equals to 2 करिए या 3 करिए. So 1/√n is less than to 1. Similarly it is less than to 1/√2. Okay, or n equals to 3, 4. Okay, so that's why we are replacing. Okay, all terms. Okay, so mathematically it is correct. Okay, so next is the limit. So if limit n tends infinity, even not equals to 0. Not equals to 0 means it may be infinity. Only the condition is it is not 0. If its limit is not non-zero, then the series summation even must be divergent, provided that it is the positive term series. Okay, so this is the test for divergence, or sometimes it is also known as Cauchy divergence test. Okay, so let us see some examples. So prove that the following series 2/3 factorial plus 3/4 factorial plus 4/5 factorial plus and so on is convergent. Then find its sum. Okay, so first we show it is convergent. So its nth term will be, if you see the nature of terms, 4/5 factorial, first one is the 2/3 factorial. So denominator में हमारा क्या 1. Okay, more than 1 है. Okay, plus 1 है. So n plus 1/n plus 2 factorial. Even is n plus 1/n plus 2 factorial. So if you put n equals to 1, you will get first term, and for n equals to 2, you will get second term. Okay, so it is the nth term. Okay, so if minus 1 upon n plus 2 factorial. This equals to n plus 2 upon n plus 2 factorial minus 1 upon n plus 2 factorial. Okay, so now simplify here 1 upon n plus 1 factorial. First term, just break it n plus 2 factorial, so it is n plus 2 into n plus 1 factorial. So n plus 2 we cancelled out by this n plus 2. So 1 upon n plus 1 factorial minus 1 upon n plus 2 factorial. So now we have to find partial sum. Okay, the Sn is nothing but first sum un plus u2 plus up to plus un. Okay, so now write down all the values. So u1 is 1 upon 2 factorial minus 1 upon 3 factorial. So this is the u1. Then similarly u2 is 1 upon 3 factorial minus 1 upon 4 factorial. So this one and similarly it comes here. Okay, write it here. Okay, so now if you see the Sn, so this 1 upon 3 factorial cancelled out by this one. Similarly 1 upon 4 factorial is cancelled out this one, and so on up to here. Only the last term minus 1 upon n plus 2 factorial will remain non-zero. Okay, so finally its sum is 1 upon 2 factorial minus 1 upon n plus 2 factorial. Okay, so Sn, if we take limit here tends infinity. Okay, so 1 upon n plus 2 factorial will go 0. Okay, because जब भी आप इसको ब्रेक करेंगे तो क्या होगा, it will have n plus 2 into n plus 1 n plus 2 into n plus 1 into n minus 1 into n minus 3 up to 3 into 2 into 1. So if we take limit, this term will go 0. Okay, so second term will turn 0. Only the first term will remain non-zero. So its sum is 1 upon 2 factorial, that is 1 upon 2. It means the partial sum is finite. It means the series is convergent. Okay, it is the finite quantity series is convergent. Hopefully everything is fine. Okay, so if you have any doubt you can unmute and tell me. Okay, so next is the Cauchy fundamental test. It is already okay told. Okay, so if it is non-zero, then the series is divergent. Now example, test the convergence of the series. So under root 1 upon 4 plus under root 2 upon 6 plus under root 3 upon 8 plus and so on up to plus under root n upon 2 into n plus 1 plus x. So here un is under root n upon 2 into n plus 1. If you see the terms, it's nth term in the numerator 1, 2, 3 and so on. Okay, it is already given basically here. Nth term. No need to identify. It is already provided in the series. Okay, so now find the limit. Okay, so now first simplify, then apply the limit. Okay, so if you simplify and take outside from the denominator n, so n will be cancelled out by this n. Okay, so finally we have this 1 upon 2 into 1 plus 1 upon n. So its limiting value is 1 upon root 2 and it is non-zero. It means, and series is positive term series. So from the Cauchy fundamental test, okay, for divergent it is not convergent, hence it is divergent series. Okay. Oh, completion test नहीं हुआ था अभी तक, sorry.
एक्सक्यूज मी सर.
Yes बोलो.
सर पिछले वाले एग्जांपल फिर से बता दीजिए, वो डाइवर्ज क्यों कर रही है?
कौन सी ये?
हाँ, un तो फाइनाइट आ रहा है ना.
No, yes, you nicely asked. Actually, we are talking about series, not convergent. Sorry, not sequence. Actually, the series is nothing but the sum of infinite number of terms of a sequence.
Yes.
Okay, so it is not sequence, it is a series. Okay, and I will show you. Okay, that is the necessary condition. This one, yes, this one, yes. Necessary condition for convergent series. So I think I already explained. I just recalling this. If a positive term series is convergent, then its nth term tends 0. ये हमारी सीरीज क्या convergent है, then इसका जो nth term होगा, nth term क्या un है, okay, tends 0. So don't confuse with un and Sn. Sn is the sum of first n terms and un is the nth term of the series, not sum of first n terms. It is the nth term of series and Sn is the sum of first n terms. Okay.
Yes.
So if un tends 0, then series may be convergent, may be divergent. But if un not tending to 0, it means if un tends non-zero value, then the series is not convergent and we have positive term series. So it is either convergent or divergent. So even not tending to not tending to 0, it means series must be divergent. Okay, so बहुत सिंपल है. आपके पास nth टर्म होगा, उसकी लिमिट वैल्यू लिमिटिंग वैल्यू निकालिए. If it is 0, then it may be convergent, may not be convergent. But if it is non-zero, then it must be convergent. That is known as Cauchy fundamental test of divergence. Okay, यही मैंने बताया. सिंपल अगर क्वेश्चन पूछा, शायद अदर सेक्शन में यही प्रॉब्लम हुई थी, लोग कंफ्यूज हो रहे थे un और Sn में. un आपका nth टर्म है, Sn आपका सम ऑफ फर्स्ट n टर्म्स है. Okay. Okay,
Yes.
so hopefully it is fine now. Okay. So now, yes, actually comparison test नहीं हुआ था, मुझे लगा हो गया. Okay, no problem. So let me define. Okay. वहाँ पर आप सिंपल समझ सकते हैं क्योंकि हमारी इनइक्वालिटी मैंने बताया था. So right side हमारा क्या छोटा है, लेफ्ट साइड से राइट साइड इनफिनिटी, तो लेफ्ट साइड तो इनफिनिटी हो गई. Okay. इस तरह आप उसको समझ सकते हैं, no problem. So now comparison test. So if two positive term series summation un and summation vn be such that un is less than or equals to vn for all values of n. Okay, so means if this inequality holds for all values of n, means for all terms of the series un and series vn, then there are two results. Okay, or there are two conclusions. So first one is if. So देखिए हमारी ये इनइक्वालिटी पहले हम समझा देते हैं. इनइक्वालिटी में आप समेशन साइन दोनों साइड अप्लाई कर दीजिए, समेशन un एंड समेशन vn. सो मान लीजिए हमारी जो लेफ्ट साइड है, मान लीजिए फाइनाइट है, लेफ्ट साइड यदि फाइनाइट है तो राइट साइड मे बी फाइनाइट, मे बी नॉट फाइनाइट, मे नॉट बी फाइनाइट क्योंकि लेफ्ट साइड हमारा क्या छोटा है. बट इफ summation vn is finite, then summation un will always be finite. I'm right?
Yes, sir.
Yes. Okay? क्योंकि हमारा ग्रेटर इनइक्वालिटी आ रही है ना. सो देखिए फर्स्ट रिजल्ट हमारा क्या लिखा, इफ समेशन vn is convergent. Convergent means we are talking about finite value. Okay, so summation un will also be finite. It means summation un is convergent. Okay, ये हमारा पहला केस तो क्लियर हो गया होगा, आपको याद भी नहीं करना पड़ेगा, माइंड में रखिए आप लोग. ठीक है, नाउ दूसरी पॉसिबिलिटी चेक करते हैं. ओके, सपोज समेशन un is not finite. Summation means not finite means it is infinity, and that means series un is divergent. यदि हमारा लेफ्ट साइड मान लीजिए फाइनाइट नहीं है, और यदि आप राइट साइड देखेंगे, राइट साइड इज ग्रेटर देन टू लेफ्ट साइड. So if left side is not finite, then right side will also be not finite. It means if series un is divergent, then series vn will also be divergent. Okay, so that is the second result. So if summation un is divergent, then this implies series vn is divergent. So इन एक के बारे में इंफॉर्मेशन हमारे पास, दो सीरीज है हमारे पास, तो हम दूसरे के बारे में इंफॉर्मेशन फाइंड कर सकते हैं. These are the two results. Okay, तो आप इनइक्वालिटी याद रखिए और इनइक्वालिटी के थ्रू आप ये रिजल्ट आप अपने आप बना सकते हैं. ठीक है, सो होपफुली कंपैरिजन टेस्ट इज ओके, क्लियर. यस, ओके. नाउ अनदर फॉर्म, कंपैरिजन टेस्ट इन लिमिटिंग फॉर्म, दैट इज इट इज इन इनइक्वालिटी फॉर्म, एंड नाउ अनदर केस इज इन लिमिटिंग फॉर्म. ओके, सो नाउ अगेन वी हैव टू सीरीज, summation un and summation vn. Okay, so be such that limit n tends infinity un upon vn, okay, is finite quantity provided that it is non-zero. So if un upon vn tends non-zero finite quantity, then series un and series vn converges or diverges together. It means the nature of both the series will be same. Okay, if its limiting value is non-zero finite. Okay, so हम देखिए अच्छा ये नेचर क्यों सेम हो रहा है आप लोग बताइए जरा यहाँ पर जो आपका लिखा लिमिटिंग केस कोई एक्सप्लेन कर सकता है नेचर क्यों सेम हो रहा है? यस यस एनीवन प्लीज who can explain?
सर
Yes.
सर अगर मान लीजिए यूएन सर फाइनाइट आएगा और वीएन सर इनफाइनाइट आ जाए
नो नो मैं उस केस में आ रहा हूँ आप क्यों परेशान है उस केस में आ रहा हूँ पहले मैं कह रहा हूँ given upon Vn is non-zero finite quantity then why we are telling both the series converges or diverges together हमने एक्सप्लेन लिख दिया यहाँ पर तो एक मतलब क्यों ऐसा हो रहा है आपको दिखना चाहिए ना मैथमेटिक्स आप पढ़ रहे हैं लिखना भी चाहिए ओके अब पॉइंट वाइज मान लीजिए कैलकुलेशन होनी चाहिए तो लगे क्या सही है स्टेटमेंट देखिए देखिए अब ये आपको फार्मूला दिख रहा होगा या लिमिटिंग जो भी रिजल्ट यहाँ लिखा है सो देखिए all the terms of series given can be written as some multiple of okay with terms of series Vn क्योंकि हम क्या un equals to suppose this non-zero finite value is k so un is nothing but k into Vn okay so if series Vn is convergent then series un will also be convergent क्या क्योंकि un equals to क्या है k into Vn so हमारे सारे टर्म्स क्या सब मल्टीपल है okay with other terms of other series so देखिए यदि हम एक सीरीज का सम हमारा फाइनाइट होगा दूसरी सीरीज हमारे क्या उसके सम मल्टीपल में आ रहे हैं so यदि फाइनाइट में कुछ हम मल्टीप्लाई कर देते हैं सम k then that will also be finite okay it means if one series is convergent then another will also be convergent similarly you can see divergence so if one series is divergent means its sum is infinite then if you multiply by some non-zero value then that will remain infinity it means second series will also be divergent so this is the mathematically explanation of okay that is the explanation of this of okay limiting case okay इसलिए हम कह रहे हैं कि series given and series Vn converges and diverges together okay so suppose मान लीजिए हमारा जीरो हो गया आपके केस में आते हैं आप क्या कह रहे थे बोलिए यस आप लोग कुछ कोई एक लोग बोल रहा था कि जीरो हो गया इन्फिनिटी हो गया क्या बोल रहा था
यस सर
हाँ बोलिए बोलिए आप लोग यस बोलिए
सर सर यही कह रहे थे कि सर अगर सर इन्फिनिटी हो जाता
हाँ
तो सर यूएन अगर इन्फिनिटी हो जाता तो सर वीएन वीएन भी फाइनाइट तो अगर सर यूएन सर जीरो रहता सपोज करिए
हाँ
सर
हाँ
यस सर और वीएन अगर सर जीरो इन्फिनिटी हो जाता
हाँ
तो सर ये भी पूरा सर होल जो है वो जीरो ही आता तो सर ये तब जीरो के बराबर आ जाता तब सर कन्वर्जेंस तो रह नहीं जाता ये या डाइवर्जेंस
कौन सा
सर जैसे अगर यूएन सर जीरो रहे
हाँ
यूएन
हाँ
और सर तो सर वीएन भी जो होगा वीएन वीएन भी सर जीरो ही आएगा यही मेरा कहना था
अच्छा अच्छा ओके ओके हाँ क्योंकि हमारे मान लीजिए नॉन जीरो है नॉन जीरो डिवाइड करेंगे तो Vn will also be same okay
यस सर
okay that thing you want okay we wanted to explain okay so now देखिए आप क्वेश्चन कर सकते हैं सपोज क्योंकि हम यहाँ पर बात कर रहे हैं नॉन जीरो फाइनाइट की बात कर रहे हैं केवल सपोज इट इज जीरो देखिए हमारे पास तीन केस यहाँ बन रहा है ना वन इज नॉन जीरो वन इज जीरो एंड वन इज इन्फिनिटी तीन केस बनेंगे ना यहाँ पर लिमिट लेंगे तो जीरो लिमिट आएगी या तो नॉन जीरो आएगी या तो इन्फिनिटी आएगी ओके सपोज इट इज जीरो so what does it mean by zero if the limit या un upon vn is zero इसका मतलब क्या होगा बताइए un upon vn tends zero it means growth rate of un
यूएन इज
very very less compared to growth rate of vn it means we will get un less than or equals to vn this inequality will come okay if un upon vn tends zero okay so ये हमारी इनइक्वालिटी आएगी और यहाँ से हम ये रिजल्ट हम फाइंड कर देंगे दोनों रिजल्ट अप्लाई कर देंगे सपोज इट इज इन्फिनिटी so it means suppose un upon vn tends infinity it means growth rate of un is more compared to growth rate of vn so we will get un greater than or equals to vn okay so फिर से हमारे यहाँ पर इनइक्वालिटी रिवर्स हो जाएगी जो आप देख रहे हैं कंपैरिजन टेस्ट, और इसके अकॉर्डिंग हमारे फिर से रिजल्ट आता है। ओके, सो दिस कंपैरिजन टेस्ट, ओके, with the result of these two we can, okay, find the nature of positive term series. यहाँ पर लिमिटिंग फ्रॉम उनके नॉन जीरो भी यूज करते हैं, बट समटाइम्स यदि आपका जीरो आ जाता है वहां से क्या इनइक्वालिटी बनाइएगा और इनइक्वालिटी से आपके पास ये रिजल्ट। ओके, सो होपफुली कंपैरिजन टेस्ट इज वेरी इंटरेस्टिंग ना। यस
एक्चुअली सर,
यस
सर वो जो मतलब यही जो केस है जिसमें फाइनाइट क्वांटिटी आ रही है, लिमिट फाइनाइट है, तो इसमें डाइवर्ज जब दोनों कर रहे हैं un और vn, तो फाइनाइट कैसे आ सकता है? मतलब ऊपर भी इंफिनिटी है नीचे भी इंफिनिटी है।
एक्चुअली आप समझ नहीं रहे, पहले हम देखिए प्रूफ नहीं कर रहे हैं। देखिए आप जो पूछ रहे हैं ना, हम प्रूफ नहीं कर रहे हैं कि अरे सर ऊपर भी इंफिनिटी आ रहा है, क्योंकि हम यहाँ पर सम ले रहे हैं। क्या बताइए?
नहीं
सम तो नहीं ले रहे हैं ना। देखिए आपको पता होना चाहिए कि डाइवर्जेंट का मतलब क्या होता है, इवन टेल्स नॉन जीरो वैल्यू, नॉट जीरो वैल्यू, समटाइम्स इट मे बी जीरो। जैसे अभी हमने प्रूफ नहीं किया ऊपर, if limit is zero then it may be convergent, may not be convergent, but if its limit is non-zero then it must be divergent। देखा अभी ऊपर हमने। देखिए जब इन्फिनिटी आता है तो आपको भी पता है हॉस्पिटल रूल लगते हैं बहुत सारे रूल। ऐसा तो है नहीं कि हम वहां पर छोड़ देते हैं। ओके, तो हम प्रोसीड करते हैं ना विद हेल्प ऑफ रियल हॉस्पिटल रूल। ओके,
अच्छा हाँ यस सर ठीक।
ओके, सो होपफुली एवरीथिंग इज फाइन। ठीक है, so this is the comparison test either in inequality form or in limiting form. Okay, both you can apply. So let us see. So with the p series, sometimes it is also np series. Okay, so this np series we will through comparison test. So the series summation, अभी बहुत सारे क्वेश्चन करेंगे, आप लोग परेशान हो, comparison test के बहुत सारे क्वेश्चन करने वाले हैं अभी। So the series summation n equals to 1 to infinity 1 upon n to the power p, that is 1 upon 1 to the power p plus 1 upon 2 to the power p plus 1 upon 3 to the power p plus and so on. Okay, is convergent if p is greater than 1. So this is convergent if p is greater than 1 and it is divergent if p is less than or equals to 1. Okay, so here there are only two cases. यदि आपका यहाँ पर p greater than 1 होगा then this series could be convergent, otherwise it is divergent. Okay, basically this result will be used directly later on. So first we see mathematically how it is possible. Okay, so let us see one by one. So case first, if p is greater than 1, p is greater than 1, so say the terms of the given series are positive, you can see. Okay, so for any p, okay, 1 upon n to the power p will always be positive. Okay, so take it p greater than 1. So 1 upon 1 to the power p plus 1 upon 2 to the power p plus 1 upon 3 to the power p and so on. Okay, so we are writing, basically we are rewriting these terms. 1 upon 1 to the power p plus 1 upon 2 to the power p plus 1 upon 3 to the power p. देखिए हमने दो दे दिए, फिर यहाँ पर क्या 1 upon 4 to the power p plus 1 upon 5 to the power p plus and so on 1 upon 7 to the power p. Then next rearrangement is from 1 upon 8 to the power p and so on. So you know for p greater than 1, so 3 is always greater than 2, and if we take the power p both side, then inequality sign will remain same. 3 to the power p will be greater than 2 to the power p as 3 is greater than 2. Now we are just taking the inverse. So you know we take the inverse, then inequality sign will be opposite. Okay, so if it is greater than, then it will be less than. 1 upon 3 to the power p is less than 1 upon 2 to the power p. So is it okay how we are writing this?
Yes sir.
Equality okay. So if someone have doubt, you can okay unmute and tell me. Okay, so it is fine. So now we add 1 upon 2 to the power both side. So if we add same quantity both side, then inequality sign will remain same. Okay, so 1 upon 2 to the power p plus 1 upon 3 to the power p is less than 1 upon 2 to the power p plus 1 upon 2 to the power p. Okay, so so if you simplify right side the expression, you will get 2 upon 2 to the power p. Okay, this one. So it means this the value of this first arrangement or rearrangement is less than 2 upon 2 to the power p. Similarly, see the second arrangement. So similarly, 1 upon 4 to the power p plus 1 upon 5 to the power p and up to this. So if you replace these terms by 1 upon 4 to the power p. In previous one, we are replacing basically his term by 1 upon 2 to the power p. Okay. So this one you can write. So it is I think 4 times 4 upon 4 to the power p. It means it is okay 4 upon 4 to the power p. So similarly, next one is 8 upon 8 to the power p. Okay. All right. Plug in all the values. So from equation number 1 we can write this. क्योंकि हमारे पास क्या सब में क्या आ रही है लेसर इनइक्वालिटी आ रही है लेस देन आ रहा है इट मींस राइट साइड हमारा जो यहाँ पर जो लिखा है क्या हो जाएगा लेस देन टू इज 1 upon 1 to the power p plus 2 upon 2 to the power p plus 4 upon 4 to the power p plus 8 upon 8 to the power p plus and so on. Now if you simplify this, so it is 1 to the power p plus 1 upon 2 to the power p minus 1 plus 1 upon 4 to the power p minus 1, okay, or 2 to the power 2p minus 2, okay, here 2 to the power p minus 1 and it is 2 to the power this one, okay, 3p minus 3. So it is basically geometric series, okay. So it is the infinite series. So sum is because common ratio is 1 upon 2 upon 2 to the power p because देखिए square लिखा है ना 4 upon 4 and cube. So common ratio R is here 2 upon 2 to the power p. Okay. So sum is 1 upon 1 minus 2 upon 2 to the power p. So it is the infinite sum of infinite geometric series. Okay. So if you simplify this one, now if you see the right side, now apply the p is greater than 1. So 1 upon 2 to the power p minus 1 will be finite. Because p is greater than 1, suppose 2 to the power p minus 1 is infinity, then 1 upon 2 to the power p minus 1 will be finite quantity. Okay, so it means whole sum is finite quantity. So if you see in context of comparison test, so the right side sum is finite quantity. So the left side sum which is less than to right side must be finite. It means p greater than 1. The series is convergent. Okay. Is there any doubt? Yes. No doubt. Okay. So yes.
सर
Yes. Please. बोलिए.
सर यहाँ पे सिंपली अगर हम nth टर्म ले लें जो कि 1 upon n to the power p होगा
1 upon
n to the power p, तो उसको अगर हम प्रूव करते हैं लिमिट n टेंड्स टू इनफिनिटी अगर वो 0 हो रहा है तो भी तो ये सीधे कन्वर्जेंट हो जाएगी.
नो ये गलती आप करेंगे ना. देखिए हमने क्या कहा था, यदि लिमिटिंग वैल्यू 0 हो रही है then that case series may be convergent may not be convergent. अभी आगे हम लोग देखेंगे ना. देखिए आप जो कह रहे हैं ना, मैंने पहले ही बता दिया था n tends infinity un tends 0 means series may be convergent may not be convergent. अभी मैंने बताया एक्चुअली शायद इस टाइप का कोई क्वेश्चन नहीं हुआ क्या अभी. अच्छा दिस वन देखिए यहाँ पर यस इस टाइप का क्वेश्चन नहीं हुआ है शायद. चलिए आगे करेंगे क्वेश्चन. तो 0 जा रहा है इसका मतलब ये नहीं कि आप कन्वर्जेंट ही होगा, सीरीज में भी डाइवर्जेंट. ओके, आप इसी को देख सकते हैं ना. आप जो अभी क्वेश्चन हमने किया इसी को आप देखिए ना. यहाँ पर देखिए आप कह रहे हैं ना 1 upon n to the power p. So 1 upon n to the power p and we are taking p greater than 1. Okay, so it will always 0. Its limiting value will be 0.
Yes.
Okay, but it is convergent. Okay, but sometimes it may be divergent. I will tell you one example. Don't worry. Okay, I will tell you. Okay, don't worry. So अभी हम p greater than equal to 1 देंगे ना, इसी में आ जाएगा. p greater than equal to 1 करेंगे. So 1 upon n हो जाएगा. देखिए रिजल्ट नहीं निकला. So 1 upon n is 0 but it is divergent. So it is the counter example. Okay. Keep in mind these examples as a counter example. Okay. So let us see another case. That is for t equals to 1. आपका केस आ गया. ठीक है. plus 1 upon 2 plus 1 upon 3 plus 1 upon 4 plus and so on. So फिर से हम क्या rearrange कर रहे हैं इसको, ओके rearrange क्या हमें कैलकुलेशन हमें सम फाइंड करना, तो हम rearrange कर रहे हैं, ऐसा नहीं कि हम कुछ एडिशन है एडिशनल टर्म्स लिख रहे हैं या कुछ आप ओमिट कर रहे हैं, we are writing all the terms but we are rearranging, okay. So 1 plus 1 upon 2 plus 1 plus 3 1 upon 3 plus 1 upon 4 यहाँ लिखिए, फिर हमने क्या 1 upon 5 से स्टार्ट किया up to this plus and so on. So we know 3 is less than 4, okay, it is general truth, okay. So if we reverse 1 upon 3 will be greater than 1 upon 4. Now add 1 upon 3 both side, 1 upon 3 both side, sorry 1 upon 4 both side, so you will get 1 upon 3 plus 1 upon 4 and this. So we get greater than equal to, because 1 upon 4 is less than 1 upon 3 and we are okay, okay 1 upon 4 we are adding both sides, so it will be greater than 1 upon 2. Mathematically you can also calculate, okay, there is problem. So 1 upon 3 plus 1 upon 4 is greater than 2, okay. Similarly for this, so if you replace all the terms by 1 upon 8, see the second arrangement, so that will be greater than 1 upon 8 4 times, that is 1 upon 2. Second, okay, now third, now replace 1 upon 16, yes 1 upon 16, okay, so you will get this, so it is also greater than 1 upon 2. Now put all the substitutes or put all the values into this, so if you plug in all the values, then here the equality will replace by greater than, क्योंकि हमारे सभी क्या ग्रेटर हो रहे हैं और हम क्या इससे रिप्लेस कर रहे हैं लेस देन वैल्यू से, so this equality sign will be replaced by greater than inequality, okay. So infinite series is greater than 1 plus 1 upon 2 plus 1 upon 2 plus 1 upon 2 plus and so on. So if you see right side, अब देखिए अभी ग्रेटर देन इक्वलिटी आ गई, यदि हमारा राइट साइड इंफिनिटी हो जाए, then लेफ्ट साइड will also be infinity. Why infinity? Because it is the greater than compared to right side, okay. So if you see right side, it is 1 plus 1 upon 2 plus 1 upon 2 plus and so on. So its SN, if you find SN, that will be 1 plus n minus 1 upon 2, n minus 1 upon 2. Now take the limit, so that will be infinity. So right side sum of right side series is infinity, so left side sum will also be infinity. Then from the comparison test, the series is divergent, okay. Now अच्छे से clear हो गया होगा, for p equals to 1, that is divergent. Similarly for p less than 1, okay. So if we know 1 upon n to the power p is greater than 1 upon n for all values of n equals to 2, 3, 4, we take p less than 1, then cross check, take any value which is less than 1 and this inequality must be hold, okay. 1 upon n to the power p is greater than 1 upon n, okay. So now if we take n equals to 2, so 1 upon 2 to the power p is greater than 1 upon 2, okay, and similarly 1 upon 3 to the power p is greater than 1 upon 3. So we have 1 upon 1 to the power p plus 1 upon 2 to the power p plus 1 upon 3 to the power p plus and so on. So it will be greater than, now plug in all the values, 1 plus 1 upon 2 plus 1 upon 3, this one. So if you see right side, so it is again infinite series, that is 1 plus 1 upon 2 plus 1 upon 3 and it is nothing but summation 1 upon n, okay. It is nothing but summation 1 upon n, and from the previous result we have already proved this series is divergent, okay. Right side हमारा क्या summation 1 upon n ही तो है right side, okay. 1 plus 1 upon 2 plus 1 upon 3. So in case second we have proved that this is divergent, and by using comparison test, so if it is divergent then left side will also be divergent. These are simple cases but these are very interesting, okay. Through comparison test we saw the nature, okay. Now let us see one more question, that may be the last question, okay. Hopefully you all have the class from 1 p.m. yes, class आप लोग 1 बजे से, yes, okay. So yes sir, okay, let us complete one question only, after that I will take attendance. So test okay, so test for convergence, the series whose nth term are given, it is under root n upon n square plus 1. So here un is given. Un is nothing but under root n upon n square plus 1. Now we are going to apply comparison test of the limiting form. Generally we apply the comparison test of limiting form. Okay. So for apply comparison test, in the comparison test, if you remember, we should have two series, summation un and summation vn. But here the one series is given only, that is un. Okay, whose nth term is under root n upon n square plus 1. So with the help of this un, we identify vn. So procedure for identifying the vn. So first we take highest degree term from the numerator and then highest degree term from the denominator and simplify the common terms. So देखिए इवन में हम क्या करेंगे, यहाँ पर इवन में क्या हाईएस्ट डिग्री न्यूमरेटर में क्या अंडर रूट n है, सिंगल है, ऑलरेडी हमारा कॉमन है, हम एक टेक. नाउ इफ यू सी denominator, in denominator we have n square plus 1. So highest degree term is n square. Okay, so take it outside. So finally क्या होगा, n square बाहर आएगा, ये हो जाएगा हमारे पास 1 plus 1 upon n square. So हमने n square आपके denominator से लिया और under root n ऊपर से लिया. So vn is nothing but under root n upon n square. Okay, so after simplification it is 1 upon n to the power 3 by 2. Now हमारे पास un भी हो गया, vn भी हो गया. Okay, now apply the limit form. So take limit n tends infinity un upon vn. Okay, limit n tends infinity un upon vn. So if you apply limit, okay, so just value रख दीजिए un और vn की, root n upon n square plus 1 into n to the power 3 by 2. So that is nothing but this 1 upon 1 plus 1 upon n square. If you apply limit, it is 1. Okay, which is non-zero finite quantity. Okay, so from limiting form of the comparison test, okay, both the series un and series vn either convergent or divergent. Okay, अब यहाँ से हमारा फाइनल हो गया कि हमारी सीरीज un और सीरीज vn या तो कन्वर्ज करेंगी या तो डाइवर्ज करेंगी. अब देखिए हमारे पास जो हमारा vn सीरीज समेशन vn, summation vn is nothing but summation 1 upon n to the power 3 by 2. Okay, so if you just recall, I just explained the p series. It is having 1 upon n to the power 3 by 2. If you compare with p series, here p equals to 3 by 2. Here we have p equals to 3 by 2, which is greater than 1. And we know p series is convergent for p greater than 1. Okay, so p is 3 by 2, which is greater than 1. It means the series vn is convergent, hence series un will also be convergent. Okay, कोई डाउट हो तो बताइए आप लोग. यस, किसी के पास भी जो भी हमारी एक्टिंग स्टूडेंट है, मेरे टीचर का काम होता है सबको लेके चलना. Okay, किसी के पास भी डाउट हो तो आप पूछ सकते हैं, अदरवाइज I stop here. Yes, sir.